Before we start solving this problem, did you know there's a straightforward way to simplify even the most complex looking expressions? Today we're breaking down this equation step by step. You'll see how easy it can be to handle expressions like this, and we'll also explore why solving problems like this actually matters. Equations like this might seem intimidating, but they play a big role in many fields, from physics to engineering. Breaking down complex expressions helps us make sense of the world mathematically, whether it's calculating forces, designing structures, or just improving our problem-solving skills. Simplifying equations is a powerful tools. Many people find expressions like this one confusing with so many variables and terms. It's easy to feel lost in all the letters and numbers, but don't worry. The trick is to look for common factors and group them terms. By the end, you'll see that simplifying this expression isn't just about finding an answer, it's about developing skills that apply to everything from data analysis to computer science. Let's break it down. Step 1. Step 1 is finding the GCF, greatest common factor, which is 5, and then we simplify by dividing 15, 15, negative 5 and negative 5. Step 2 is by grouping them together. Now, having them grouped, we look for common factors, which the first pair is 3 and y, and then we divide each term, leaving us with 3y x plus z. Here are two negatives, so you have to be careful. The common factor is z, and we divide each term, leaving us with z, negative z, x plus z. Here's the moment where it all clicks. By breaking down the expression into parts and factorizing step by step, we've simplified it to having this long, complex problem to going smaller. This process shows how simplifying expressions can turn complex data into more usable forms like this one, something that especially important in fields like coding, physics, and finance. So we took this long problem and we simplified it to this here.